Hello, and welcome to the BMC Quick Course Series. My name is Ken Zolkowski, and I'm a lead product developer based in San Jose, California. Total Object Manager, or TOM, is a component of MainView Auto Operator. TOM maintains the availability of resources such as started tasks and USS processes in the ZOS systems that make up your enterprise. One of the strengths of TOM is the flexibility it provides to define objects to be monitored and managed. In this session, I'll describe the best way to define a Db2 subsystem to TOM. A Db2 subsystem needs 4 address spaces to operate on a ZOS system. DBM1 for database-related services, MSTR for a variety of system-related functions, DIST to provide support for remote request, and IRLM for Db2's internal resource lock management. You can also specify an administrative task scheduler address space by defining an ADMT address space. By default, the Db2 master address space manages the starts and stops for the ADMT, DBM1, DIST, and IRLM address spaces, or subtasks. If any subtask fails, the master address space will stop the remaining subtasks and then itself. If the Db2 master address space fails, the subtasks will come down on their own. When TOM restarts the Db2 master address space, that restart will cause a restart of the subtasks by the master address space. To define a Db2 subsystem to TOM, you will define a Db2 master address space. Optionally, you can define the subtasks for the subsystem as well as a rule in Auto Operator to ensure a stopped subtask status is set properly. Defining the subtasks is optional because the master address space, and not TOM, starts and stops the subtasks. Define the subtasks to TOM only if you want to monitor the availability of one or more of them. Otherwise, don't define them. We recommend that you define only the master address space to TOM. Let's get started. For the object name, enter a name in the format sysplexname.sysname.label. The label in this case is the subsystem ID plus the string MSTR. As you can see from the valid systems field, we have specified one system in the valid systems list. In this case, it's the local system. You can add an optional description. Here, I have used the object reference variable of user1, and I am substringing the value associated with this variable starting at the second character for a length of 4 characters. Using the object reference variable like this will help with the definition of any additional Db2 subsystems in this definition base. We issue the next command to move on to the next dialog panel. To illustrate the result of what we specified in the description field from the previous slide, here are the results of a browse real-time command for the object. Notice how in the object description field we now have the name of the subsystem. Because we use the user1 variable, you won't need to change the object's description when additional subsystems are defined. Just change the value in the first user attribute field, and that change will flow into all the attributes that must be unique from one subsystem to the next. And I'll show you how to do that in the next few minutes. After pressing the next command on the panel where we entered the object description, we are presented with this panel. Here we supply the started task name, a start event, and a stop event. Here I have entered the name of the started task for the Db2 master address space using the user1 object reference variable. Again, when I need to define other Db2 subsystems, I will not have to edit the STC name field because the correct information will already be available. Enter the next command to continue. Here's the startup validation event we mentioned in the previous slide. We've provided an ID in the message ID field. To make the event specific for this Db2 subsystem, we have also provided additional text identifying this message in the message field. Here is the stop validation event for this object. Again, using the message ID and message fields, we specify the particulars for this object. Notice the originating STC field. We've used the value master. This is because this message is not issued by the Db2 master address space, but by the ZOS master address space. After we have defined the start and stop events, we need to identify the start commands to be used to start the Db2 master address space. See the max start count field? We need to indicate that we want the start commands to be issued a maximum of 3 times before setting the object status to failure command count. This prevents a runaway condition, which can occur for an object that starts, encounters an abnormal condition, and terminates. When this happens, Tom will automatically attempt to restart the object. If the problem that caused the abnormal stop has not been corrected, the object will probably abnormally terminate again. A restart can happen so quickly that there is little time to make a correction. The maximum start count prevents this sequence of start, failure, stop, and then restart from happening over and over again. Lastly, we want to have Tom reset the start command count when the object terminates normally. One start command is defined for this object. You may want to evaluate the timeout value for the subsystem you are defining. Next, we want to set the attributes needed to stop the Db2 master address space. We have to consider that there may be objects that depend upon the Db2 master address space. Setting the stop all dependents or children bottom to top attribute TS ensures that a scheduled stop of the Db2 master address space will cause the dependents to also be stopped by Tom in a dependency order. We need to specify only one stop command for the object. In some instances, 4 minutes will be enough time to stop the subsystem. Some subsystems will require more time. As with the start command, we prefix the stop command with the user1 object reference variable. This ensures that we are using the proper subsystem command identifier for this Db2 subsystem. Using the user1 variable also makes this definition easy to reuse for other Db2 subsystems that need to be defined. After we have defined the start and stop command information, we will specify any dependency information for this Db2 subsystem as well as the user attribute needed to populate the user1 object reference variable. Because object dependencies vary from installation to installation, we have not identified the parent of this Db2 subsystem. You need to determine what that dependency ought to be and update the object dependency information accordingly. At the minimum, you must specify a user attribute containing the Db2 subsystem identifier. The subsystem command identifier for this Db2 subsystem is *SSNM. This value is placed in the user1 attribute field and will be used to populate the user1 object reference variable. Now we can save the Db2 master object. At this point, we have now specified the minimum attributes needed to define a Db2 subsystem to a definition base in Tom. You can specify other attributes such as scheduling, a short name for automation variables, and additional system names in the valid systems list so that the Db2 subsystem can be moved between the systems in the Tomplex. That is your choice based upon your site's needs. There are times when you may want to see the status of the Db2 subtasks. If you perform the default Db2 installation, Tom will never have to issue starts or stops for these objects. However, not defining these objects means that they will not show on views such as TOBJOR or TDEPCH. Defining the objects to Tom is the only way to include them in the views. Let's define some subtasks. As with the master object, we are following the recommended name format of sysplexname.systemname.label. We have also specified one system in the valid systems list. Again, the only optional attribute we have used is the description. We have specified the object reference variable of user1, and we are substringing the value associated with this variable, starting at the second character for a length of 4 characters. We have set the control mode of this object to suspend. In this case, Tom will recognize the need to start or stop an object, but will take no action. Leave the control mode for these objects always set at suspend. Specify the started task name. Do not specify a start or stop event for this object. Tom will automatically define an initiation event and an end of memory event for the object. Specify the start command information. Define the object as restart only. This will ensure that Tom does not take any action to start the object at system startup. The object status will be set to wait start and will stay that way until the object is started by the Db2 subsystem. Then the status will go to active. Do not provide a start command. The master address space for the Db2 subsystem will issue the start command. Now specify the stop command information. All we want to do is to indicate that the object is to use quick shutdown mode when shutsys or shutset has been issued and this object is involved. When you specify a quick shutdown mode, Tom changes the status to stopped immediately without performing any pre-stop or post-stop automation during shutsys or shutset processing. You can set a quick shutdown for objects that are managed by another scheduling product or are started manually, but their availability is still monitored by Tom. Do not provide a stop command. The master address space for the Db2 subsystem will issue the stop command. Next, specify dependencies and user attributes. The subsystem command identifier for this Db2 subsystem is *SSNM. This value will be used to populate the user1 object reference variable. Define a dependency entry to show that there is a dependency between the master and the Db2 subsystem subtasks. The parent will be the master address space in this Db2 subsystem. When the master and the subtasks have been defined, they will be visible in the TDEP-CHR view. You can define one, none, or all of the subtasks. Tom will not control the subtask because the master address space is controlling them. Because the subtasks are defined to Tom but are not controlled by Tom, there can be a problem when they are stopped by the master address space. The objects will come down, but because Tom did not command them to come down, Tom will set the status of the subtask objects from active to active error. This can be confusing and it is inaccurate. You can avoid this by defining a rule in the local auto operator that will trigger when Tom detects the end of memory event for one of the subtasks. The rule will issue a Tom console command that will change the status of the object to stopped. Let's define a rule to change a subtask status to stop. This will be a journal type rule. We are looking for a message from the Tom journal. The message ID is IC1707I. We are looking for the message IC1707I EOM event, whatever the rule ID is, fired for whatever object name this is for, attributes end. The Advanced Variable Dependency panel is important. You need to specify these variables and values to make sure that we only fire for the end of memory event for the subtasks. We want the rule to fire only when we have reached the end of the event reporting in the Tom journal. This is why it is important to look for the word end in the message. Change plex.system to the name of the sysplex and system that the objects are running on. If the length of this part of the object's name does not equal 12, in this case it does, then the length value on the left function will need to equal the length of this part of the object's name. Determine the length of the object name. If it does not equal 20, then replace the value of 20 with the length of the actual object name. When the rule fires, it will take an action against the object named in the message. Auto operator will issue a modify command to Tom. The command will issue the change status function against the object in the message. The change status function will change the status of the object to stopped if the current status begins with the string active. Any other status will cause the function to change the status to active. Now you can go ahead and save this rule. Examples of the Tom object definitions shown in this presentation can be found in the MAM STDEF member in BBSAMP. The rule to trap and take action against the IC1707I message can be found in the AAO RUL TM member in BBParm. Together, they will provide the recommended minimum definition for a Db2 subsystem. The variable QTOM_JOB_ID contains the job identifier for the TOM address space. PTF_BQO1246 needs to be applied in order for that variable to be available to a role. Thank you for your time. For more information on any BMC mainframe product, please visit the URL shown here.